All right, so now I want to graph a different quadratic function, y equals 1/2 x squared. And then we'll do all the same things that we did on the last example as well. So I'm going to select all the values of x and use the same ones that I did on both of the other examples from -3 to +3. And so when I substitute in -3, here's what the equation would look like. 1/2 times -3 squared. As always, exponents come before multiplication. -3 squared is 9. Half of 9 is 4.5. So 4.5. -2 squared is 4. Half of that is 2. -1 squared is 1. Half of that is 1/2 or 0.5. 0 squared is 0. Half of 0 is 0. And then 1 squared, you'd actually get the same output as when you input -1, because 1 squared is also +1. Half of that is 0.5. 2 squared is 4. Half of that is 2. And then lastly, 3 squared is 9. Half of that is 4.5. So I'm going to graph all those points. -3, +4.5. -2, +2. -1, 1/2. 0, 0, 1, and then 0.5. Ignore that. 2, 2, and then lastly 3, and then 4.5. It's continuous. The graph would look like this. It's still a parabola. The graph of every quadratic function is a parabola. And then I'm going to compare that to y is equal to x squared. So in red there, I have y is equal to 1/2 x squared. And then in blue, y equals x squared, because the first thing I want to do is compare the red graph to the blue graph. The red graph is like wider, or it's more open. That's what's referred to as a vertical shrink. Specifically by a factor of, so there's the acronym, by a factor of 1/2 or 0.5, either way. Okay, the vertex is right here. Again, we're taking a look at now y equals 1/2 x squared. Even though the vertex of each of the graphs are the same, vertex is at 0, 0. The graph opens up. It's a regular U shape. Sometimes you'll see in the future where the graph would open like that. That's when the graph would open down, but the graph doesn't open like that. And then the equation for the axis of symmetry, just like on the last example, the axis of symmetry goes right down the center. It's the y-axis, or the equation is actually x equals 0 for the axis of symmetry. Okay, I'm going to use an acronym for that as well. AOS is the axis of symmetry.